let us look at this question. Why does the sun rise in the west and set in the east on Venus? So let us explore. Here if you see on the earth, all the stars seem to rise in the east. They move towards the west, including the sun. So sun rises in the east and slowly move towards west. And in the evening, when you look at the western sky, you will observe that the sun slowly moves towards west coming from the eastern direction. So the motion of the sun as seen on the earth, or motion of other stars as seen on the earth, are from east to west. Now the question is, what happens on Venus? So first let us look at why does the sun rise in the east on the earth. Now this generally is attributed that the earth spins about its axis, and because it spins from west to east, so the relative motion of the sun is seen from earth is east to west. Now that's not exactly correct. Okay, so but let's see what happens on Venus. The Venus spins in retrograde way. It spins in the opposite sense that of the earth. So it spins from east to west, and hence the sun rises in the west. Now that's wrong reasoning. That's not completely correct. Let's see why. So what is a day? So it is duration needed by the planet to spin about its axis. This is what one would say. Day is decided by the spin. But again, that's not completely correct. So let us look at this position of the sky and the stars in the night time. This is found out, which is at this particular position on meridian, and the day is given as 12th of November. The time is given as 2011. Now, if you change the day, okay, from 12 to 13, exactly at the same time, that is after 24 hours, you see that formal has shifted, okay, and it is shifted towards the west. Now, if you go few minutes early, instead of 8:11, now you are going at 8:07, that is 4 minutes early. So actually it is 23 hours 56 minutes. Again, formal is coming on the meridian. So the time required by formal or a star, any star, to come from meridian back to meridian is 23 hours 56 minutes. It is less than 4 minutes by 24 hours, which we call a day. So day is 24 hours, whereas the Earth's spinning rate is slightly smaller than that. So what is a day? A day for all civilian purposes is defined as the duration between two noons. When the sun comes on the meridian, and again when it will come on the meridian. So noon is when sun crosses from eastern sky to the western sky along a line called meridian, which is line joining north-south through the exact overhead points, what we call zen. The solar day is duration between two consecutive passages of the sun over a meridian. We use this definition of day for all civilian purpose, and that's where the duration of day for sun, duration of day as seen for stars is going to be different. Now here what you observe, see that on 13th of November at 12:22 the sun is over the meridian, and if you change the date from 13th to say 14th or 13th to 12th, okay, exactly 24 hours, keeping the time same, see what happens. You're gone to 14 and the sun is again on meridian. Okay, the position of sun has not changed. You're gone to 15th November, again sun is on the meridian. So by changing 24 hours, okay, the sun remains exactly at the same location. 24 hours is the duration between two passages of sun over the meridian. Now, rotation period is, however, sidereal. The rotation period of planet gives the duration between two consecutive rising of a star or star passing over the meridian. And due to retrograde spinning, the stars will rise in the west and set in the east on Venus. Okay, the stars will rise, stars will set on Venus from west to east. What about the sun? the motion of the sun is going to be slightly different than the motion of stars. And let's see what is that. So here on the earth, say this is sun, this is the orbit of the earth, and let's suppose the earth is at this point and you are standing here, this is noon. So exactly sun is either overhead or on the meridian of the observer. After one sidereal day, the orientation of the observer is again same, but now the sun is not exactly overhead. But in order for sun to come overhead or on the meridian, the observer will have to rotate slightly more. Okay, and that is this particular position, because during that time the earth will slightly go ahead in its orbit. Now, this motion here for earth is slightly exaggerated. The duration is actually very small. Sidereal day is 23 hours 56 minutes and 4 seconds. Solar day is 24 hours. So there is a difference of just 4 minutes in case of earth. Now let's look at the formula. The formula is 1 by solar day equal to 1 by year minus 1 upon sidereal day. Now solar day we are writing as -1 with the sign convention that all motions from west to east are positive, and sitting here on the earth you will observe the sun going from east to west, and therefore there is a negative sign over here. The year the motion is revolution, which is from west to east, and therefore it is 365.25633 with positive sign. The sidereal day is the relative motion observed with respect to stars, okay, due to the spin motion. Again the spin is from west to east, and that motion we have to find out. So 1 by sidereal day will be effectively this. You can see that the positive sign 0.9972667 days. So when you convert that days by multiplying with 24 hours per day, you get about 23 hours 56 minutes and 4 seconds. Now let's apply this formula to Venus. So for Venus again we can use the same formula, but we want to for now calculate how much is the solar day. The year is known, which is the revolution period, 224.7 days, and the sidereal day is the rotation but in retrograde fashion, and therefore with negative sign. Substitute this numbers and you get 116.7 days. Now see that this is with positive sign, indicating that on the Venus you will see sun going from west to east, because it is positive sign over here. The relative motion of the sun will be from west to east. Now this may be attributed to the retrograde motion, but let's see, it is not really. So if you consider Venus were spinning from west to east like Earth, see what would have happened. You are using the same formula, but now with 243 days having positive sign, which means the sidereal motion is from west to east, and therefore you will see the stars going from east to west. When you do this calculation, the solar day still turns out to be a large number but a positive number, and what you observe therefore is the sun will still seem to go from west to east, but now with huge amount of time required, because sun will be moving very slow in the sky of the Venus. So it will take about 2984 days to complete one revolution noon to noon, but it will still go from west to east. So the spinning is not exactly directly related to the motion of the sun. It is the spinning motion as well as the revolution both together contribute. So you can say that sun should still move from west to east even on the Venus, even if it were moving spinning from west to